parameters. Out of that we have seen some of the parameters are mostly for the connection design and some of them are for the member design. So as we noted down beam, then this DFF, DJ1, DJ2, FU, FILD, K, KY, KZ, then LY, LZ. So these are the main parameters what we need. Then main, then ratio, then track. So these are the parameters which are required. So we have selected the parameters. Now we have to define the parameters. We'll go by grid for defining the parameters. Okay. So we'll just select first of all this and this grid. So the whatever common parameters are there, we will define them first. So beam one, it will be for all the members. Okay. So we have added that parameter here. We have added that parameter. Then we need DFF as 360. We will add it. FU, it will be 420. We will add it. FILD 250. These are by default values. We will just add it. KYKZ for time being will consider for these columns. KY will be 1 because it is braced frame, and sorry, I have the KZ. So KZ will consider around 1.5. This is just assumption, but in detail we have to calculate based on the stiffness. And KY it will be 1 since it is a braced frame. Okay. Then LYLZ we have to define for each member. Main 180, that is slenderness ratio. Then ratio, we will just define the slenderness ratio 2.9 so that the member capacity will be utilized up to 90%, and track 2 we need the detail of output. So we have just added the parameters, so we will assign these parameters to the structure. So this beam one we have to design all the section at every 1/12 of intersection. We will assign to view. So it is assigned to complete geometry. Then DFF parameters, it will be assigned to only beam members. We'll just select the beam parallel to Y and I'll select the inverse beam selection, and we'll just exclude the bracings from this. Okay, so all beam members are selected and DFF will be 360 assigned to this member. FY 420 it will be for the complete geometry. FYLD 250 for all the sections. Then KZ will be only for the columns. For these columns, KZ will be 1.5 and KY will be 1. For this column also, KZ will be 1.5 and KY will be 1. Main slenderness ratio for all the members 180. All members should be designed up to 90% capacity. Then track 2 for all members result we need detail output. So these are the common parameters for all the members, so that we have assigned. Now what is remaining? DJ1, DJ2, LY, LZ. So first we will apply LY and LZ. We'll go as per the grid. So first we will select these two grids. So just tell me again, what is LY? Do we need to define LY for these members? For which member we need to define LY and how much it is? Yesterday's question, repeat. So define LY, how much it will be? 2.5, 5, LY, how much?
Five.
Please. 5. Okay, so LY 5. So you just hit add, and once it is added, you have to select this member for the members for which LY is 5 meter. Okay. So for these members, LY is added as 5 meter. Then we have to define LX also. Then LX will be again 5. Again for the same members, it will be 5. Okay. For this LZ, we don't need to define because it is already considered as a half. Okay. For these columns, what will be the LY? LY will be 4.5. So we just define LY 4.5. And what will be the LZ? It will be total height
9 meters.
9 meter. We'll just select the beams parallel to I. So I have selected all the columns for which LY will be 4.5 and LZ will be 9. Okay. So LY, LZ is assigned. To beam also it is assigned. LY, LX and LZ is assigned. Now which members are remaining? Members on these grids. Again for these members, LY will be 6 meter, right? These two members, LY will be 6 meter. LY 6 meter. LX also 6 meter. For stock, which is also 6 meter. Okay. Then for the this column, the LY will be 4.5 and 5.7. So it is already broken, so we don't need to define LY separately. Only thing LZ we need to define as 5 plus 4 and 7 plus 0.7 plus 0.5. So it will be 5.7 plus 4.5, 9.
10.5.
10.5? No, it will
9,
be
9,
5.7 plus 4.5. It will be something 10.1.
10.2, I think.
5.7 plus 4.5, 10.2. So the LZ will be 10.2. LY, LY it will be for these members. Or it will not be LY, it has a break. Okay. Then LX will be 6 meter, and for these two columns, LZ is 10.2. Okay. So for column and beam, we have assigned the member parameters. Now let's check for the top member. For top member, for this we don't need to define LY because it is already have a bracing and it is at regular intervals. Only thing we need to define LZ for this member. So what will be the LZ? LZ will be the complete length. So 6.2 meter will be the LZ. Okay. So now we have assigned all the parameters. What we have to do? We have to define the check code command. So once the parameters are defined, also still we need to define dj1, dj2, right? For what we need dj1, dj2? For deflection check. So only for the member where the node is created, only for those members we need to define the dj1, dj2. So this dj1, dj2 you can define from the input file, because if you want to assign it from this command, it will be a little bit tricky and you just need to search for all the nodes. So instead of that, you can go to the input file.
कहाँ सर क्या
So we will define dj1, dj2. So simply you can mention dj1. So first select these members, right? These members. So these are the member numbers. We need joint number also. So this 47 is joint number, 66 is member number. So dj1 will be start point. So 47 will be dj1. So dj1 is 47, and for which member it is? We have to define member 66 and 78. So 66, 78. These are the two members which are having first node or first joint as 47. Okay. Then it's dj2 or end joint is what? 49.
49
Right.
yes
So
sir
this is 49. I'll just mention 49 member, again 66 and 78. So for these two members, my start node is 47 and end node is 49. So whatever difference between the two nodes, that will be the length of these two member will be considered for the deflection. So similarly, we'll add for the other members. So for these two members, it is 25 and 27. So dj1 is 25 and dj2 is 27, and for member 20, 75. Okay. So these members are done. Again for this 48, 50, 72 and 84. It will be dj2 and load is 50. And for this 26 and this is 20, 28. dj1 is 26. Members are 26 and 81. dj2 will be 28, 26 and 81. Okay. So we have defined all these numbers. Now for the roof members, for roof, this will be the complete length. for which deflection will be checked. So its start end is 25, and member are 35, 105, 36, 106. 35, 36, 105, 106. You just copy it, and DJ2 will be 26. Similarly, for this member 27 and 28, just copy this one. 27 is the start node, 28 is the end node. And member numbers are 37, 38, 107, 108. 37, 38, 107, 108. So we have defined all the DJ1, DJ2 for all the members. Just save it. So all parameters are done here. We have DJ1, DJ2, DFF we have defined as 360. The 360 is defined. So now we'll just select the command. So we need to perform the design. So we'll say check code. And another thing, we need material takeoff or weight of the total truss. So we'll just add material takeoff, and that we will assign. So we have to assign it to complete view, check code all, and still takeoff of all the members. Okay. So this parameter assignment is done. Now we have to simply run the file. Okay. So there are no errors, no warnings. Just go to output file. We will just select the failing member. So these many number of members are failing. We'll just double click on this. We'll see what it is failing. So it might be failing due to the slenderness, right? All the members are failing due to slenderness. So instead of this back-to-back bracing, if you can change it to the star bracing. Okay. If I just select a star, just 100, 100, 10, then whatever bracings are failing, those will pass. Okay. Now bracings are not failing because those were failing in slenderness. Since we have changed it to the star bracing, all bracings are passing, and also the ratio, strength ratio also got reduced. Now some beams are failing. We'll just select those beams. Okay. So first is this beam. So it is failing in again slenderness. So instead of that, we can do one thing. Instead of changing the size of the member, we can just add one tie beam here, so that it will create a what it will do. It will just reduce the effective length in minor direction, right? So if I just add this kind of beam here,
सर थोड़ा धीरे कीजिए ना.
अच्छा, ये हमने सिर्फ मेंबर ऐड किया है अभी.
वो ठीक है सर, थोड़ा
We have
फास्ट
just
चल रहा था
added,
इसलिए मैं बोला.
we have just added the member, so we'll just intersect these members so that the nodes are getting created at the intersection. We'll just create a central node. we have added a node at the midpoint with this command, insert node command, node at the midpoint. So we got the node and we'll just connect beam with this node to node. We'll just create a beam. Okay. So now we have to assign release to beams. So here specification page, from where you can assign the relay start. So this will be the start for all the beams, and there will be an end. So we assign start and end. We have to assign the property from property page. ISMB 300. So this is the start size, or just assume size we are providing. Okay, but the section size is assigned. Now what we have to define, we have to consider that member in the design. Again we will go to design part here, and then from the parameter we will assign all those things to, again, to all view. So assign to view, so all the members will be covered. TFF we just need to assign to the beams. Pretty much 10 each time. KYKZ we don't know for those members. Ratio 0.9. Track LYLZ, there is no change. Okay, so just simply run it again. Okay, so one rafter member was failing at this location. Now it is passing just because of its slenderness got reduced, and also the strength ratio also improved, right? So its slenderness got reduced from 101. Now which members are failing again? We will select from here. So this one tie member and this column member. So let's select for this member. So it is also failing in slenderness, right? And this column, it is just failing in slenderness as well, right? So here we need to change the column size only, because we don't have any alternative to add any member or for this beam also. So we'll just change the beam size and column size. We'll just select these two grids. Okay, so we'll just change this beam size from ISMB 450. We'll go to ISMB 500, and for this member also to 500. Okay, we'll just run it again. We'll see if those members are passing. Then go to select specification, 12 members. So now no beams are failing. So now even though we are observing that there are no failure in any of the member, still we have to go to the this output file, and we have to check, or we have to find the fail.
सर ये कहाँ से आ गया?
यहाँ से ये आउटपुट फाइल है आपका, यहाँ पे स्टैट आउटपुट. दिस इज इनपुट, दिस इज आउटपुट फाइल. If you click on this, you will get the design. Okay, so once you get this design, in this you have to search for the fail members. If you search for the fail, if it is there, then it will show you the fail. If not, then all the members are passing. Sometimes what happens, even though the in graphical mode you can see the members are not failing, but sometimes it happens that when you check to the output file, there are some failed members, right? So up to this clear, how to assign parameter, change the member size? Any doubt up to this?
No, sir.
पैरामीटर में
सर कॉलम बीम का सब LX LY LZ अलग अलग पैरामीटर देना होगा सर.
यस यस, वो अलग अलग आएगा, बिकॉज हर एक का लेंथ सेम नहीं है ना, सो
वो
LX
तो
LY हर एक का। आप चाहिए तो ग्रुपिंग भी कर सकते हैं। ग्रुपिंग पता है स्टैड में कैसे करते हैं? हर एक मेंबर को असाइन करना है तो आप क्या कर सकते हैं? सो ये मेरा चारों मेंबर का सेम प्रॉपर्टीज है या सेम इफेक्टिव लेंथ है। आई जस्ट सिलेक्ट, चारों को सिलेक्ट किया, कंट्रोल जी दबाने के बाद ये क्रिएट ग्रुप के लिए आएगा। ग्रुप अब आप यहाँ पे इनसे डिफाइन कर दो कि इनका LY कितना है, LY 5.0। ये मेंबर बीम सिलेक्ट करना है, ओके। सो LY 5 मीटर तो असाइन टू सिलेक्टेड ज्योमेट्री, ओके। ये असाइन कर दिया तो जिन जिन मेंबर नंबर को और ये LY 5 है, इनका एक ग्रुप बन गया। तो वंस द ग्रुप इज क्रिएटेड यू कैन गो टू इनपुट फाइल। यहाँ पे ग्रुप, एक ग्रुप का कमांड आता है डिफाइन ग्रुप करके। हाँ, ये ग्रुप डेफिनेशन आ गया। तो ये LY इतना जो हमने ग्रुप में डाला था वो आप कॉपी करके सिंपली पैरामीटर में लेके जाओ। यहाँ पे आपको डिफाइन करना है उन ग्रुप का LY। सो LY, तो इसको जस्ट मॉडिफाई करो LY 5 मीटर और जस्ट इसके बाद मेंबर कमांड डाल दो। तो ये सभी जो मेंबर्स हैं उनको आप असाइन कर सकते हो, राइट। तो आप ग्रुप कमांड से क्या होगा आपको कि आप यहाँ से ही सब एक एक देख के असाइन कर सकते हो। बाद में उसको यू कैन ट्रांसफर टू द पैरामीटर्स अंडर पैरामीटर्स, राइट। So
yes
this
sir.
is the use of grouping. Okay. Any more doubts?
अभी तो सर कल वाला देखा ही नहीं है, शाम में 4 बजे वीडियो आया है, तो कहाँ से पूछूं कुछ।
अच्छा, ठीक है। आपको कभी वीकेंड है तो टाइम मिलेगा, आप देखिए।
एक्चुअली सर वो मुझे आज आपका नंबर चाहिए था।
हाँ
मैं मुझे प्रॉब्लम हो रही थी, प्रैक्टिस कर रहा था तो मैं
हाँ हाँ
कॉल किया, बहुत पड़ गया। मैं नंबर फिर मुझे अनिल सर दिए, तो फिर मैं 4 बजे था उसी टाइम, तो मैंने आपको
हाँ हाँ।
कॉल नहीं किया कि क्लास में ही पूछ लेंगे।
अच्छा, क्या डाउट
वो
था आपका?
तो सब एडिटर में जाके हम लोग कर रहे थे, सिंटैक्स एरर बता दे रहा था बार बार।
आपने कुछ
लोड,
सिंटेक्स गलत डाला होगा वहां पे।
फिर
आपने
वही सिंटेक्स को 1 बाय 1 करके डाले तो वो करेक्ट ले लिया।
ले लिया ना?
हाँ
ओके। तो अभी इसमें कुछ डाउट नहीं होगा तो हम नेक्स्ट टॉपिक को स्टार्ट करते हैं।
सर, ये तो इंडस्ट्रियल स्टील में हो गया। अगर ये आरसीसी में इसी तरह पैरामीटर अप्लाई करना होगा?
आरसीसी में ये LY LZ नहीं रहता है। आरसीसी में आपको सिर्फ कॉलम का इफेक्टिव लेंथ देना रहता है, बिकॉज आरसीसी में क्या है कि आपका टॉप लेंथ या ऐसा कुछ रहता नहीं है। माइनर लैटरल टॉर्सनल बकलिंग या माइनर एक्सिस बेंडिंग ये उतना होता नहीं, क्योंकि उसका कंक्रीट का स्टिफनेस ही इतना रहता है कि वो माइनर एक्सिस में कभी बेंड होता नहीं है। कोई भी आरसीसी बीम लोगे आप, वो माइनर डायरेक्शन में, जब तक उसको माइनर डायरेक्शन में लोड नहीं लगता है तब तक वो बेंड नहीं होता है। स्टील का क्या होता है, उसके मेजर एक्सिस में भी लोड लगता है तो भी वो माइनर एक्सिस में बेंड होता है, बिकॉज इट 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 स्टिफनेस, स्टील का जो स्टिफनेस है सेक्शन का, वो बहुत कम है। और हमारा ISMB सेक्शन आप देखेंगे तो स्लेंडर सेक्शन से बहुत, उनका
यस
वेब
सर।
का थिकनेस कुछ भी नहीं है। उसके ऊपर अगर आप मेजर एक्सिस में भी लोड डालोगे तो भी उसका वेब बकल हो जाएगा। तो उसके लिए ये पैरामीटर, स्टील में पैरामीटर जरूरी है, ये LY LZ। कंक्रीट में आपको सिर्फ इफेक्टिव लेंथ फैक्टर जो हम कल डिस्कस किए, स्टेबिलिटी इंडेक्स वगैरह से, तो वो
यस सर।
आपको डालना पड़ेगा कंक्रीट में।
तो ये इंडस्ट्रियल बिल्डिंग ये डिजाइन हो गया सर? ये फाइनल हो
हाँ
गया?
ये, हाँ ये डिजाइन हो गया अभी आपका। सब लोड लगा दिया, मेंबर डिजाइन हो गया।
सर
पैरामीटर्स यही आएगा। कोई भी आप स्टील का कोई भी बिल्डिंग ले लो, ये शेड ले लो या बड़ा वाला बिल्डिंग ले लो, कुछ भी ले लो, पैरामीटर्स विल बी द सेम, ओनली इट विल वेरी डिपेंडिंग ऑन द विच कोड यू आर यूजिंग। उसका जो लिमिट्स है, लाइक DFF लिमिट या स्लेंडरनेस लिमिट, इट विल वेरी डिपेंडिंग ऑन द country's code only.
सर
हाँ
सर, जैसे अगर कुछ शेड में सर जैसे कर्व्ड रहता है ऊपर से, जो
हम्म।
टॉप पोर्शन है ना, तो कर्व्ड
हाँ
मेंबर्स रहते हैं स्टील के, तो सर वो चीज कैसे होगा सर उसमें असाइन
तो
वगैरह?
वो तो पाइप मेंबर रहता है, और उसको भी असाइन जो कर, उसको जो बनाते हैं, जब बनाते हैं ना, तो स्टैड में तो कर्व मेंबर आप नहीं बना सकते ये डायरेक्टली। तो
यस सर, यही
आपको
पूछना
थोड़ा
था।
सा जब मेंबर आप मॉडल करोगे, तो उसको छोटे छोटे पीसेस में आपको बनाना पड़ेगा, ऐसा तभी वो बनेगा। मतलब यू यू हैव टू क्रिएट अ मल्टीपल नोड्स, राइट। ये ऐसा नहीं बनेगा पूरा स्टैड में। तो ये आपको ये स्टेट मेंबर दिया, ये स्टेट मेंबर दिया, ये स्टेट मेंबर दिया, ऐसा करना पड़ेगा। और जब आप इसका पैरामीटर डिफाइन करोगे, तो ये इसका पूरा एल या एल ये हो जाएगा। इवन दो यू हैव क्रिएटेड मल्टीपल नोड्स, बट इसका एल और एल ये पूरा हो जाएगा। एंड विंड कैलकुलेशन के लिए भी सेम है जो हमने रूफ का लिए निकाला। तो सेम देयर इज प्रोविजन इन द कोड फॉर द राउंड शेप रूफ और डोम शेप रूफ। तो उसके हिसाब से आपको यहाँ पे लोड लगेगा वो पूरा नीचे से।
ओके ओके सर।
सर ये इंटरपोलेशन आप कैसे निकालते हो वो मुझे बता दीजिए, तो दिक्कत हो रही थी।
कौन कौन सा इंटरपोलेशन?
विंड विंड लोड में सर जाके रूफ का विंड इंटरपोलेशन करते ना है,
हम्म।
तो वो सर मैंने केस 1 पर तो किया, तो वो आ गया था लोड कितना आया था, लेकिन
हाँ
उस रूफ पर आके वो मुझे दिक्कत होती है। आप कहाँ से 1.1 लिए, 1.9, 1.7 समथिंग इस तरह कुछ, ये सब तो समझ गया था सर।
ओके।
हाँ रूफ का सर,
ये वाला
हाँ सर,
या
ये कैसे आया, कहाँ से लिए, किस तरह करके, वो थोड़ा
ये
दिक्कत
तो
हो रही थी।
टेबल, ये तो टेबल ही दिया है ना कोड में, सेपरेटली टेबल ही है वो।
तो सर वो जैसे 10 से 20 डिग्री के बीच में इंटरपोलेशन होगा, तो वो इंटरपोलेशन कैसे होगा?
एक- ये रूफ का है बराबर।
हाँ।
तो ये 0 डिग्री है, और हमारा स्लोप कितना है, 14 डिग्री है।
14
तो
डिग्री।
10 के बीच में आएगा,
यस सर।
बराबर। सो 10 का कितना है 1.4, 20 का कितना है 1.4।
यस सर।
तो इनके बीच में इंटरपोलेशन करना है हमें।
किन के बीच में?
20, 10 और 20, और ये 1.4 और 1।
तो ये कैसे इंटरपोलेशन होगा, वो एवरेज करके होगा, मल्टीप्लीकेशन नहीं हमको आ रहा था समझ में।
इंटरपोलेशन अभी है, एक मिनट।
एक्चुअली सर ये मैं पढ़ा नहीं था, हम लोग का इंडस्ट्रियल बिल्डिंग दिया ही नहीं था।
नहीं नहीं, वो ठीक है, लेकिन इंटरपोलेशन हम ये मैथमेटिक्स में किया है ना स्कूल में।
भूल गया हूँ सर थोड़ा मैं भी।
ये 10 डिग्री है, ये 20 डिग्री है, बराबर।
यस सर।
बीच में
यस
आपको
सर।
कितना है 14 डिग्री है।
हाँ।
इसमें कितना है ये वैल्यूज अभी, 10 20 का ये मान लीजिए 1.4 और 1 है। ये हमारा
यस।
केस कौन सा था, ये था शायद। तो ये 2 और -2 और 1.5 है। तो ये -2 हो गया, ये -1.5 हो गया। मुझे इसके बीच का वैल्यू चाहिए।
यस सर।
तो हम ये दिस माइनस दिस, करेक्ट।
यस सर।
ये डिवाइड बाय दिस माइनस दिस, बराबर।
यस सर।
ये एक हो गया इंटू तो 14, ये वैल्यू के लिए चाहिए -10, कितना है 0.2। तो इसको आप इसमें से माइनस करेंगे, दिस माइनस दिस, तो ये आपका आ गया -1.7 आ जाएगा ये। तो ये 1.7 आ गया, ये हमने कितना निकाला है यहाँ पे, -1.7।
ओके सर,
करेक्ट।
करेक्ट।
ये अपना मैथमेटिकल है, आप गूगल पे भी डालोगे ना, ये मिल
मैं
जाएगा कि
हाँ सर,
इंटरपोलेशन
मैं
कैसे
देखता हूँ।
करते हैं।
ओके सर।
हाँ, सिंपल।
यूट्यूब पे कई वीडियोस है अविनाश भाई, उससे देख सकते हो आप।
ओके ओके, भूल गया था मैं बिल्कुल।
अरे ऐसा मैथ इसलिए तो नहीं भूलते ना, मैथ तो इसलिए हमेशा के लिए चाहिए आपको। अच्छा, ओके, सो अभी नेक्स्ट स्टार्ट करेंगे हम, बेसिक ऑफ एंकर बोल्ट्स देखते हैं फिर।
सर आज के लिए रहने दीजिए सर, पीछे का भी रिवाइज करना है।
अब लेकिन मेरा टाइम खत्म हो जाएगा, ऐसा हो जाएगा।
सर हम लोग का भी समझिए, बहुत लेंदे बारीकी से एक एक चीज देखना पड़ता है एकदम, दिन दिन पर बैठ
नहीं,
जाता हूँ सर।
वो बात सही है, लेकिन अभी नहीं लेंगे तो क्या होता है, सेक्शन है ना, एक्सटेंड होते जाएंगे ये सब।
कोई इशू नहीं सर, हमको सीखना है सर। वो स्टेट प्रो बहुत डिमांड है मार्केट में, इसीलिए मैं बोल रहा हूँ कि थोड़ा हम लोग भी बारीकी सीखें इसका।
बाकी लोगों का क्या कहना है अभी?
सर ले सकते हो आप सेशन, अगर मेरे को तो कोई दिक्कत नहीं, बाकी और से पूछ लो एक बार।
हाँ, मतलब सब लोग को या तो ये चाहिए ना। क्या व्यूज है बाकी लोगों का? नेक्स्ट टॉपिक स्टार्ट करें या कल करना है? I don't have any issue in continuing right now also, because we can cover some of the part.
सर अभी सिर्फ आप थ्योरी लोगे ना एंकर बोल्ट का?
हाँ, अभी एंकर बोल्ट का सिर्फ थ्योरी ही है, क्योंकि उसका डिजाइन है ना बहुत वास्ट है
ठीक है,
वो,
सिर्फ
मतलब
तो
ऐसे
सर थ्योरी
कवर भी
अभी
नहीं कर
करा
सकते।
दो फिर, अगर ऐसा है तो।
हाँ थ्योरी है तो कोई प्रॉब्लम नहीं सर।
हाँ, ये एंकर बोल्ट का वैसे भी हमारा डिजाइन पूरा नहीं है, सिर्फ बेसिक हम सीखेंगे कि एंकर बोल्ट का लेंथ कितना चाहिए, क्यों चाहिए, उसको कैसे डिजाइन करते हैं, मतलब उसके फिलोसॉफी क्या रहती है डिजाइन का, तो उतना ही है। फिर हम बेस प्लेट जो है वो हम डिटेल में विथ एग्जांपल देखने वाले हैं।
ठीक है सर।
एंकर बोल्ट तो
ठीक है
सिर्फ
सर, फिर
थ्योरी
अभी
ही है।
एंकर बोल्ट आप कंटिन्यू कर लीजिए।
हाँ, ओके, तो मैं फिर से स्क्रीन शेयर करता हूँ। एंकर बोल्ट का सिर्फ आपको मतलब ज्यादा डिटेल की जरूरत नहीं है, कभी इंटरव्यू में कोई क्वेश्चन पूछेगा तो उसके लिए हम कवर कर रहे हैं, लेकिन बेसिक इसका डिजाइन जो है वो अमेरिकन कोड के हिसाब से है, और सिर्फ अमेरिकन कोड में ही आपको एंकर बोल्ट कैसे डिजाइन करते हैं, क्या करते हैं वो मिलेगा, लेकिन दैट इज वेरी वास्ट टॉपिक, मतलब उसमें बहुत सारी चीजें हैं चेक करने के लिए। तो हम सिर्फ बेसिक देखेंगे जो आपके रिलेटेड काम आएंगे अभी, राइट। तो मोस्ट ऑफ द टाइम एंकर बोल्ट डिजाइन करने के लिए स्प्रेडशीट्स अवेलेबल रहते हैं, पीआईपी स्टैंडर्ड जो है। मैं आपको एक ये भी दे देता हूँ आपको, एक पीआईपी स्ट्रक्चर इसका है एंकर बोल्ट के लिए, तो वो मैं आपको एक ग्रुप में डाल देता हूँ, तो वो भी आपको आसानी रहेगी समझने के लिए। ठीक है, अभी नहीं मिल रहा है, जब मिलता है तो मैं आपको ग्रुप में डालने के लिए बोल दूंगा। ठीक है, basic of anchor bolts and base plate design. Base plate we will see in the detail how to calculate its thickness and deflection and all those things. So today we'll just discuss about the anchor bolts. There are few types of anchor bolts, right? There are some grades also. These all grades are as per American code, but in India we also follow the same grade almost. In India we follow the grade 4.6, 8.8, 10.2, whereas in American standards these are grade 36, grade 55, grade 105. So जो हमारे यहाँ पे फॉलो होता है वो है 4.6 एंड 8.8. तो वो क्या है वो मैं बताता हूँ नेक्स्ट स्लाइड्स में. So there are some few types of anchor bolts. All these are the cast in anchor bolts. Means whenever construction is going on, during that time we place these anchor bolts, or we can put these anchor bolts in pocket. So these are the during construction of the concrete or foundation or pedestal. So for these bolts called as cast in anchors, these are four types of bolt anchor bolts are there. First is hex headed bolt with washer. So this is hexagonal headed nut along with washer. This is one type. The other is same bolt with but in L shape. This is J shape anchor bolt. All are having hex nut and washers. And this is stud. So where these bolts are used? So first bolt is used for the heavy equipment or structural columns fixing. Like if you want to fix the now what warehouse we have designed, if you want to fix it along with the pedestal, then this kind of bolts are used. Okay, so it has a specified length which will be embedded in the concrete, so that it will give you sufficient tension capacity. And these two types of bolts are mainly for the small equipments like pumps or some cooler or small equipments where load is not more, but only those equipments needs to be held in place by some fasteners, so that these bolts are provided. And these studs are the bolt type where we need embedded plate, right? Sometimes we provide insert plate. You must have heard about insert plate. So that insert plate will have welded to these studs, and these studs will then be concreted or embedded in the concrete before the pouring. So these are the cast in situ anchor bolts. For these bolts, we can provide a pocket. For this type of anchor bolt, where straight type anchor bolt, the pocket may not be for the complete length of the bolt, but it will be for the certain height. Okay, pocket will be there for the certain height of the anchor bolt, and that will be provided just for the alignment of the base plate of the equipment or of the structural column. This L type and J type bolt will have a complete pocket provided, and these bolts mainly installed or provided at the time of installation of the equipment. So during the casting of pedestal, the pocket will be left to accommodate this size of the bolt, and then once the equipment is arrived on the site, these bolts are placed in that pocket, and then it is grouted to fill that pocket, so that the bolt will not move in line. Okay, and these are directly welded to the insert plate and just connected with the reinforcement like beam bar or column bar, and then concrete will be poured. So these are the cast in bolts. Similarly, we have some other bolts where sometime what happens, we may constructed something, but later on we found some changes in there, changes due to the equipment size, or we need to add some beams for the additional support. So that in that case, we need to install the bolts in the casted concrete. So for that, these are the post-installed anchors. So post-installed anchors are those anchors which are installed in the concrete after erection of the concrete or after completion of the anchor. So you must have heard about Hilti anchors. So Hilti anchors are the post-installed anchors where they use some specific chemicals to provide the bond strength, right? So what are these types? One is adhesive anchors, then undercut anchors, torque controlled expansion anchors, sleeve type anchors, and strut type and drop in type displacement control expansion anchors. So these are the various type of anchors. Sometimes this sleeve is already cut, and this once the sleeve is inserted, then these anchors are torqued or rotated or tightened to, so that these sleeves will get expand and it will provide a resistance against the tension. So these are the adhesive anchors where the chemical, once the anchor is placed in that holes, drilled holes, then the chemical will be injected so that it will form the bond between the anchors and that concrete material. So these are the expansion, like sleeve expansion. These are also the same, where the sleeve is inserted and then anchor bolts are tightened so that they will expand the sleeve and it will get a resistance for the tension, right? So these are the same anchors, and this is the stud anchors which are used for the small equipment, so its effective embedment is quite less. So these are the typical cast-in anchors and post-installed anchors. So now sleeves. So if you can see, these are the sleeves which are provided in during the construction of pedestals. So these are different type of sleeves for certain length of the anchors. So what these sleeves mean for? So when precise alignment of anchors is required during installation of structural column or equipment, when we want precise alignment of the uh, structural columns or equipment, because structural column or equipment comes with the base plate welded to them, right? So in and these anchors are installed during the construction. So sometimes it happens that the bolt hole locations in the base plate and the location of anchors, there could be a slight mismatch in the dimensions. So in order to make the adjustment at the site, these anchors are provided with the sleeves so that they can slightly shift these anchors, right? So that is the first purpose of the sleeve. And second is when anchors will be pre-tensioned to maintain the bolt under continuous tensile stress during load reversal. So when the pre-tension bolts are used, the, there will be a pre-tension sleeves are provided to keep the bolts under tension after tightening the nuts. So once we tighten these nuts up to its required torque, then there will be a tension in the bolt, and those sleeves will helps to because of this nut at the bottom, that sleeves will help to keep the tension intact or keep the bolts under tension. So this is the main purpose of the sleeves. One is for the alignment, and second is to maintain the tension in the bolt when the bolts are pre-tensioned. Pre-tension bolts are used mainly for the heavy equipment or high-rise buildings. For normal structures, we use the normal bolts like bearing type bolts. Okay. Then these are the anchor chairs, right? So these are the anchor chairs. So what is the purpose of these anchor chairs? When we want to keep when we keep these bolts uh, inside the pedestal, right? During that time, during pouring of the concrete, it may happen that due to the concrete load, these bolts will miss the alignment. So in order to keep this bolt in align at its original place or original position, this type of chair or anchor chair is provided so that bolt will remain in its position. There will not be a misalignment of the bolt, so that they don't need to shift during the fixing of the base plate. For some of the large equipment where the number of bolts are more, so here you can see the huge number of bolts. So in that case also we need this template. This is called the template. It is generally provided by the manufacturer, equipment manufacturer. So they just keep all the bolts in place, and whenever equipment comes along with the base plate, they will just keep over it. And since this reinforcement is quite dense, and if you see the concrete area is quite big, so while pouring the concrete, there will be a misalignment of the bolts, and if there is a misalignment of the bolt for such a heavy equipment, then it will create a problem at the site for its erection. So in order to keep its alignment, this kind of chair is provided or a template is provided so that the all anchors will remain in the place. And once the equipment is erected or the concreting is done, then this chair will be this template will be removed, and will equipment will just rest on these uh, anchors, right? So this is the one of the most important advantage of putting these chairs. These chairs we don't need to design for these templates, because it is the erection contractor or mechanical contractor who works on the site. He will provide all these necessary elements to keep to reduce any problem at the site. Okay, so now about design of the anchor bolts. So anchor bolts are designed uh, for the two forces. One is for the tension and other is for the shear. Anchor bolts are never designed for the compression. Right? Just keep in mind, whenever there is a compression in the column, that compression will be passed through the base plate, through the bearing, to the concrete pedestal just below it. And if there is a tension, then that tension will be taken by the bolts, and shear also by the bolts. So if you want to avoid shear to be transferred to the bolt, we can go with the shear lugs, right? Shear lugs are there to take the shear on the anchor bolt, right? But for that we need to provide this kind of arrangement. This is called shear key, right? This is called a shear key, which we need to provide in the concrete pedestal. And this portion, this plate section, or you can provide eye section, this is called the shear lug. So whenever there is a shear at the junction of base plate and concrete, all the shear will be registered by these shear lugs, and bolts will not have any shear on it, right? So bolt will be designed only for the tension. The other way is to transfer shear to the pedestal is through the welded washers. So whenever they normally we provide a oversize hole, right? For the base plate, we normally provide oversize hole of 1 mm or 2 mm, right? So in that case, what happens whenever there is a shear, the bolts are slide, or the base plate will slide against the that oversize hole. In that case, the shear will not get transferred to the pedestal, but it will be just registered by the friction between the base plate and the concrete. So in order to transfer that shear to the bolts or to the concrete to the bolts, we provide a washers, and those washers are exactly as the same diameter of the bolt, and those are welded to the base plate, right? So once those washers are welded to the base plate, then there will be a no sliding of base plate, because whatever forces are there when the shear will come, since washers are the same size of the anchor bolt, then those will bear against the bolts will bear against the washers, and the force will get transferred to the base plate directly. So base plate will not slide. The force will get transferred to the base plate, and from base plate it will get transferred to the pedestal through the friction. Then it will be registered by the friction between the base plate and pedestal. So this is how we can transfer the shear from the base plate to the pedestal. So this is the force diagram for the bolts. So this is FCZ, MX, MCY. So this FCZ, it will have this is the total tension. So it will be divided, or you can say it is a direct tension coming in the member. So that will be divided into all 4 bolts, right? FCZ is PZ, FZ, PZ, FZ. So it will be same for all the members, right? These are the 4 reactions getting created in the anchor bolts. And this is the moment MCY, right? So MCY will be the what it will create. It will create the tension in these 2 bolts, whereas compression in these 2 bolts, right? Because of lever arm, right? Are you getting this movement? How the movement is getting transferred? This is important. Huh? How the movement is getting transferred between the anchor bolts. So in case of bolts, right, we have 4 bolts like this, right? One is this axis, another is this axis. So when movement is in this direction, these 2 bolts will have tension in it. So these 2 bolts will be under tension, and these 2 bolts will be under compression. So this tension and compression, or we can call it as a pull push. So this will be calculated by this total movement divided by the spacing between the bolts. This is the lever arm, right? So by this method we can calculate the pull push in the anchor bolt. So 2 bolts, because of movement, it is not a direct movement, it is bending the stress, or you can say bending stress, and that because of that stress, this tension and compression is getting created in the anchor bolt. So because of this MCY, we are getting tension in these 2 bolts and compression in these 2 bolts. Similarly, due to MCX, we will get tension in these 2 bolts and compression in these 2 bolts. Okay, so this is the force diagram when we have a biaxial bending in the column. So now the most important factor is what should be the design of anchor bolts, whether it should be the base plate connection. When we say gusseted base, like base plate and pedestal connection, that is one of the connections. So how we want the failure of that connection? If there is a chance of failure, then what type of failure should be there? So there are 2 type of failure. One is ductile failure and brittle failure. So by this name, would you predict what kind of failure it will be if we say ductile failure and if we say brittle failure? So what we are allowing to fail in this case? If it is a ductile failure, what we need? Anyone? If it is a ductile failure, what should we fail first? I'll just draw one sketch.
Bolts.
This is my pedestal. These are the anchor bolts, right? It will have some reinforcement. This kind of arrangement footing. So if these are the anchor bolt, this is pedestal. So when I'm saying I need to have a ductile failure, what should fail? This pedestal should fail or concrete should fail? Bolt should fail.
Bolts
Or a
should fail.
Okay. And if it is a brittle failure means bolt will remain
Pedestal.
as it is, pedestal will fail. So which failure is better?
So ductile failure is better.
Okay, and why it is?
So it gives indication to us that it
Yeah,
will going to further. We have time to think
correct,
about the problem.
correct. So ductile failure is always preferred because first thing, the bolt will not fail suddenly. Before failing, it will absorb lot of energy whenever there is a seismic or wind. Before failure, what will happen? It will try to elongate, right? As it will elongate, it will show you the deflection of the structure, but it will not fall the structure immediately, right? In the column or in the beam, you can find there is some displacement or deflection or some odd shape you can find because of elongation of these bolts. So how the bolt will elongate? So initially bolt will be like this, right? Once the force will come, the bolt will try to elongate. Its area will get reduced at some location. So area will get reduced. Another, since still force goes on increasing, its areas further reduce, and ultimately after the reaching to its yield strength, then the bolt will get break, right? It will break somewhat like this. So up to this point, it will give you indication. It will show you the warning. It will show you the structure deflected, and by that time, it will absorb lot of energy due to the seismic or due to the wind. So once you can see this deflection or this elongation, then you can just do the retrofitting work for these bolts, and you can replace these bolts with the new bolts, or you can just provide some additional supports in the structure, or you can just make some arrangement to strengthen this connection. So that's why always we need a ductile failure of the connection. Ductile failure means our bolt should fail first before failing the concrete. Okay, so this is clear. Now how we can achieve that? How we can achieve the ductile failure of bolts? Should we go on increasing the diameter of the bolt? If we just increase the diameter of bolt, so if we are requiring 20 diameter of bolt, should we go up to the 30, 36 just to achieve the ductility, or will it be achieved with the increase in diameter? It will not, right? Because we don't know how much load will be coming, even though we have estimated some load. But if there is sudden large earthquake, then it cannot be able to sustain this bolt, right? So in order to make the failure ductile, what we need is we need to strengthen the pedestal, right? We just need to strengthen the pedestal. So this reinforcement is there, which is required as per the design of the pedestal, right? We have some forces here. This is shear force, this is axial load. There will be if it is a fixed base connection, then there will be some movement. If not, then there will be only axial force and shear. So for that, we'll just work out the this will be the cantilever part. We will just work out the movement, and for that movement, we'll just work out the steel, right? So this is the design for the pedestal. But what what we need is we need to transfer the tension coming in these bolts. That bolt we need to transfer to the pedestal. Whatever tension coming in the bolt or whatever tension carried by these bolts, that need to be transferred to the pedestal. So how we can transfer that? So this is my pedestal. I am having 4 number of bolts. I can show you some other sketch. So this is my base plate. I'll just pick out this piece. This is my concrete pedestal. Okay. So this is base plate, this is steel, and these are the anchor bolts. So I'll be having some reinforcement for this pedestal. I'll be having some reinforcement somewhere here. Okay. Similarly on other side. Right. This will be the pedestal reinforcement. Right. It will be somewhat like this, having some stirrups kind of arrangement. Okay. So this reinforcement is based on the pedestal design. Now I have to transfer the tension of these anchor bolts to the pedestal. So what I need is, if I just draw a section, so section, we have this section here. I'll just copy this one. So we have a reinforcement somewhere here. We have reinforcement somewhere here. So whenever there will be a failure, the failure will be at somewhat this degree. It is around 30 degree with the horizontal. So there, if we see this angle, it will be 30 degree, around 30 degree. So this is how the failure will occur of the concrete due to the tension in the anchor bolt. Right? This is one of the failure. So when there will be a huge tension, this much of portion of the concrete, this much of concrete portion will fail out simply. Right? This is called a cone failure. This is called a cone failure. So in order to avoid this cone failure, if this reinforcement is well within the range, so that range is, if this is the my embedment length, right? This is my embedment length for the bolt. So this is 250, I say, embedment length, or the anchor bolt is embedded in concrete for 250 meter length. So when the this reinforcement is within the HEF by 3 zone, right? HEF by 3 means its embedment depth divided by 3. So this bolt should be, it should be in the range of HEF by 3. So that will be 250 divided by 3, which comes, so it should not exceed, the rebar should not exceed more than this distance. So it should be, how much is 250 by 3? So 83 mm. So this distance between the rebar and center of anchor bolt, it should not be more than 83 mm, but at this case it is more exceeding more than 83 mm. So in that case, what we can do, we can add an additional rebar just near to this bolt. Similar rebars on this side also, right? And in plan we can see like this somewhat. We can add one more bar here, another bar here. So like this, we can add these rebars. And these all are additional rebars just to transfer the tension in the bolt to the pedestal. Now, just putting the rebar will not suffice our requirement. The first thing is that this rebar should have the development length beyond this length, right? this should be the LD provided. It depends on the bar diameter, right? And on the downside also it should be LD. So above this crack portion, on top and bottom on both the side, it should have sufficient development length to transfer the total tension. So sometime what happens, just because of short embedment length of the anchor bolt, this LD required is not sufficient. So in order to reduce this LD, we can add more number of bars. So if we can add two number of bars, we can simply add two number of bars, then my LD will get reduced by half, because I have added the reinforcement more than the actual required. So if I am requiring X amount of reinforcement to transfer the tension in the anchor bolt to the pedestal, that if and I am providing 2x, then my LD will become half, right? So that we can reduce by the ratio of actual reinforcement required divided by reinforcement provided. By that percentage, we can reduce the development length. So if you don't have sufficient space to provide sufficient length to provide LD, you can increase the diameter of the bolt, or you can increase the number of the rebar, so that the LD will get reduced. And the area required for the transfer of this tension in the anchor bolt is calculated by total tension in the anchor bolt, right, divided by Fy, 0.87 Fy. How we calculate the stress in rebar? The total axial force divided by 0.87 Fy. Fy is the grade of the steel. So that much area will be required to transfer the total tension in the bolt to the concrete, right? Got this one?
Yes, sir.
This is quite simple, but sometimes difficult to understand. So this is how, instead of increasing the diameter of the bolt, we can increase the reinforcement in the pedestal, so that the pedestal will get sufficient strength for the failure due to the anchor bolt, and the bolt will fail first before failing the concrete. So this is how we can achieve the ductile failure of the anchor bolt. Okay. So next is the minimum criteria for the anchor bolts. So when we provide a cast-in headed anchor bolts, so minimum is 6D edge distance from the edge of the pedestal to the center of the bolt. So here you can see what I have provided is, so 116. So for bolt size of 20 mm, almost I have provided 6 times of D, right? This is 116, 6 times is 120. So almost I have provided the same. Similarly, center to center also I have provided 6D. In other direction it is more than 6D. So this is 6D is the minimum edge distance for the bolts. Minimum 4D for low strength bolt and 6D for high strength bolt. Low strength means 4.6 grade, high strength means 8.8 and 10.2 grade bolts. Embedment depth, minimum 12 times of bolt diameter should be the embedment length for the bolts, but it can be customized based on the tension in the column. So you can go up to 30D as well to get the sufficient bond strength and strength of the bolt. The spacing between the anchors is 4D for cast in situ bolts and 6D for the pretension bolts. This is for the higher equipment. You can go for the 6D. Small equipment or pin type connection, you can go for 4D also, because in pin type connection there is no movement, so there is no chance of bursting of concrete. Okay, so then next is, okay, so ductile design we have just discussed, that how we can achieve the ductile design. Requirement to achieve the ductile design, this is what we have discussed, and this is the advantage of ductile design. So design consideration for ductile design of anchor bolt is anchor shall be designed to govern by tensile or shear strength of the steel, and steel shall be ductile material. So anchor bolts, whatever anchor bolts are, whatever material we are using for the anchor bolt, it should be a ductile enough, right? So as per our code, I think as per 13920, it mentioned that the whatever material or whatever steel we are using for the uh, reinforcement in case of ductile design, it should have minimum 14% of elongation. So that still qualifies for the ductile reinforcement. So the same criteria is for the anchor bolts also. Whatever material we are using for the anchor bolts, it should have sufficient ductility, and the attachment connected by the anchor to the structure shall be designed so that the attachment will undergo ductile yielding at a load level no greater than 75% of minimum anchor design strength. So in that case, in this case, we are just designing the anchor bolts for its 75%, means the complete uh, connection of base plate and anchor should have the capacity, or should be designed to 75%. Should be utilized up to 75%. There should be a margin of 25% in it. So it should be designed to 133%, so that once the 75% load will arrive on that connection, then it will start to yielding, right? Then where it can be designed or where it can be used, where there is a cyclic load. Cyclic load means seismic and wind. So these are the two areas where we need to use this kind of arrangement, like ductile arrangement. Because of cyclic loads, there could be a continuous tension compression in the members. So that will, if it is ductile, then that forces will be dissipated or will get absorbed due to that ductility. So requirement to achieve ductile design, we have just checked that we need to provide additional reinforcement like this vertical rebar or stirrups, just to take care of the shear and tension in the anchor bolts. So this is the basic for the anchor bolts. Design part, mainly design of anchor bolts is just the its area into the grade of the bolt, but mainly design is related to the pedestal. So pedestal design, we can just do the normal design, and for the additional reinforcement, we can just work out the tension in the rebar and total area of steel required, and additional rebars we can put surrounding the anchor bolt, and that should be HEF at a zone of HEF by 3. So this is how we can just achieve this connection as a ductile connection. So any query on this? In next session, we'll see the design of base plate. We'll see the example, fixed connection, fixed base plate and pin base plate connection, how we can calculate its thickness. Okay, any query up to this on anchor bolts or anything?
No, sir.
Okay. So I'll just post that PIP standard, which is for the anchor bolt. Okay. Once I have got that, I'll put it on the, or I'll ask you to put it in the classroom so that you can go through it.
Yes, sir.
Okay, so we'll stop here today. And if you have any doubts, we can have it in next session. Okay.
Okay, sir. Good night, sir.
Good night. Good night, everyone.
Good night.